NASA's recent lunar missions have underscored the challenges and complexities of space exploration, particularly in the quest to return humans to the Moon and eventually to Mars. A recent report from NASA highlights the mixed results from Intuitive Machines' second lunar lander mission IM-2, which concluded prematurely after a difficult landing that left the spacecraft on its side. On March 6, 2025, the IM-2 lunar lander named Athena touched down approximately 1,300 feet from its intended landing site at Mons Mouton on the Moon's south pole. The landing occurred at around 11:30 a.m. Central Standard Time, but the spacecraft's landing configuration was less than ideal, preventing it from fully operating its scientific instruments. Just 12 hours later, the mission ended prematurely when the lander's batteries were depleted. Despite the unfortunate circumstances, the mission did yield valuable data. It successfully transmitted approximately 250 megabytes of information back to NASA, including images of its landing site and indications of the drill's deployment from the Polar Resources Ice Mining Experiment 1'1 suite. Nikki Fox, Associate Administrator for Science at NASA, emphasized the significance of exploring challenging lunar environments, stating, "Each success and setback are opportunities to learn and grow." This mission was part of NASA's Commercial Lunar Payload Services (CLPS) initiative, which seeks to engage private companies in lunar exploration. Joel Kearns, Deputy Associate Administrator for Exploration in NASA's Science Mission Directorate, acknowledged the disappointment surrounding the IM-2 mission but reaffirmed the agency's commitment to supporting commercial vendors as they undertake the complexities of lunar landings. The IM-2 mission was the second attempt by Intuitive Machines to land on the Moon following the successful touchdown of its Odysseus spacecraft in February 2024. However, the challenges of lunar landings remain significant, as evidenced by both missions. The IM-2 lander's fall was reminiscent of the Odysseus landing, which also faced operational difficulties after an imperfect landing. Looking forward, Intuitive Machines has 2 additional missions planned for NASA, with IM-3 and IM-4 set for 2026 and 2027 respectively. These upcoming missions will continue to contribute to NASA's goal of establishing a sustainable lunar presence and preparing for future manned missions to Mars. In a parallel development, NASA is also preparing to launch the SPHER observatory, designed to map 450 million galaxies over a 2-year period. This ambitious mission aims to explore fundamental questions about the universe's origins and the formation of galaxies. Scheduled to launch soon, SPHER represents a crucial step in advancing our understanding of cosmic evolution and the very fabric of spacetime. As NASA navigates these challenges and opportunities, the agency remains focused on the future of lunar exploration and the broader implications for human spaceflight. The lessons learned from each mission, whether successful or not, will be instrumental in shaping the next generation of exploration technologies and strategies, paving the way for humanity's journey into deeper space. In a significant development aboard the International Space Station, ISS Expedition 72 has officially changed command as NASA astronaut Sunita Suni Williams handed over control to Russian cosmonaut Alexei Ovchinin. This ceremonial transition took place on March 7, 2025, marking a pivotal moment as the current crew prepares for their return to Earth, while a new group of astronauts is set to join them in orbit. During the change of command ceremony, Williams expressed gratitude to the global community that supports space exploration. "Just wanted to say thank you to everybody around the world, all the control centers, friends and family who are out there, all our trainers, all of the folks who have gotten us ready to come here and fly in space," she stated. Williams, along with fellow crew members Nick Hague, Butch Wilmore, and cosmonaut Alexander Gorbanov, is scheduled to return home following the arrival of the SpaceX Crew 10 mission targeted for March 12 and 13. The incoming Crew 10, which includes NASA's Ian McClain and Nicole Ayers, Japan's Takuya Onishi, and Roscosmos' Kirill Peskov, will officially join Expedition 72 once they enter the ISS. This mission will be significant for NASA and SpaceX, representing the 10th crew rotation under NASA's Commercial Crew Program and the 11th human flight overall. Preparations for Crew 10's launch are well underway at Kennedy Space Center. The mission is set to lift off from Launch Complex 39A at 7:48 p.m. Eastern Time on March 12. Embarking on a nearly 5-month mission that will conclude with a return to Earth in July. The Crew 10 astronauts are poised to conduct over 200 scientific experiments and technology demonstrations while aboard the ISS, focusing on research that could facilitate future human exploration beyond low Earth orbit. This crew rotation comes at a crucial time as the ISS team wraps up various research initiatives. Notably, astronauts are investigating the impacts of microgravity on human physiology, including studies on bone density loss and cognitive function during extended stays in space. Nick Hague recently collected blood samples to analyze bone recovery, while his colleague Don Pettit set up equipment to study fluid behavior in microgravity, a project aimed at enhancing disease detection and material development. The importance of this mission extends beyond the immediate scientific goals. The arrival of Crew 10 will also allow the Crew 9 members, who have been aboard for an extended 8 months due to delays with Boeing's Starliner spacecraft, to finally return home. This situation underscores the ongoing challenges and complexities of human spaceflight, particularly as NASA and Boeing navigate the hurdles posed by the Starliner's operational issues. NASA has accelerated the timeline for the Crew 10 mission, creating an opportunity for a smoother transition between crews and ensuring that critical research continues uninterrupted aboard the ISS. As teams finalize checks on the Falcon 9 rocket and Dragon capsule, the anticipation builds for what promises to be a landmark year in human space exploration. Looking ahead, the space community remains focused on the potential advancements that the research conducted on the ISS can bring to future deep space missions. As we witness the handover of command and the continual exchange of crews aboard the ISS, the legacy of international cooperation in space exploration continues to unfold, paving the way for humanity's next steps beyond our planet. In a remarkable display of inspiration and scientific inquiry, NASA astronaut Tracy Dyson recently engaged with students at the Elsie Whitlow Stokes Community Freedom Public Charter School in Washington, D.C. On March 5, 2025, Dyson, a member of Expedition 71, participated in a live Q&A session sharing insights from her extensive work aboard the International Space Station ISS. This interaction underscores NASA's commitment to not only advancing space exploration but also nurturing the next generation of innovators. Dyson, alongside her crewmates Matthew Dominic, Michael Barrett, and Jeanette Epps, answered a myriad of questions, shedding light on the diverse scientific missions conducted in orbit. During her time in space, Dyson executed a range of technological experiments, including remotely controlling a robot on Earth and utilizing a 3D bioprinter to create cardiac tissue samples. This groundbreaking work has the potential to revolutionize organ transplants on Earth, highlighting how space research can impact life beyond our planet. Every experiment we conduct is not just for the sake of science, it's about paving the way for future exploration and advancements in healthcare, Dyson remarked. The educational outreach did not stop with Dyson. On March 10, NASA astronaut Don Pettit will connect with students from Oregon, answering pre-recorded STEM-related questions from his vantage point on the ISS. This initiative, hosted by the Oregon Charter Academy, aims to raise awareness about career opportunities in science, technology, engineering, and mathematics (STEM). Pettit's engagement is part of a broader effort by NASA to inspire young minds and encourage them to pursue careers in fields that are critical for future exploration. Meanwhile, the space agency is also preparing for the imminent launch of SpaceX Crew 10, scheduled for March 12, 2025. Crew 10 will transport astronauts to the ISS, where they will overlap with the current Crew 9 team, which includes Butch Wilmore and Sunita Williams, 2 astronauts who have been stranded in space for nearly 9 months. Initially intended to be a short mission, their stay was extended due to malfunctions in the Boeing Starliner spacecraft that prevented their return. The situation with Wilmore and Williams has garnered significant media attention, especially following claims from SpaceX CEO Elon Musk suggesting political motivations behind the delay in their return. Musk alleged that offers to expedite their homecoming were rejected due to the Biden administration's desire to avoid benefiting a perceived political ally. However, NASA officials have strongly denied these assertions, reinforcing their commitment to astronaut safety as their top priority. As Crew 10 prepares for its launch, the astronauts will undergo a final quarantine period to ensure their health ahead of the mission. "This is a huge mission for us on Crew 10," said NASA Commercial Crew Program Manager Steve Stick during a recent briefing. The crew will perform an essential handover with Crew 9 before their expected return on March 19. The upcoming missions reflect NASA's ongoing dedication to not only scientific discovery but also to fostering public interest in space exploration. As these astronauts continue to push the boundaries of human capability in space, their stories serve to inspire future generations. The agency's Artemis program, which aims to return humans to the Moon and eventually facilitate crewed missions to Mars, further illustrates its commitment to leading the way in space exploration and discovery. As we move forward, NASA's multifaceted approach, engaging students, conducting impactful research, and ensuring astronaut safety, will undoubtedly play a crucial role in shaping the future of space exploration and the next generation of scientists and engineers. The excitement surrounding these developments promises a vibrant future for both space travel and education in STEM fields. In a significant development for the International Space Station ISS, NASA has announced a change of command for Expedition 72, marking a pivotal moment as preparations ramp up for a crew transition. On March 7, 2025, astronaut Suni Williams formally handed over command to Russian cosmonaut Alexei Ovchinin during a ceremony that underscored the collaborative spirit of international space exploration. Williams expressed her gratitude to the teams supporting the mission, stating, "Just wanted to say thank you to everybody around the world, all the control centers, friends and family who are out there, all our trainers. All of the folks who have gotten us ready to come here and fly in space." As Williams and her crewmates, Nick Hague, Butch Wilmore and Alexander Gorbanov, prepare for their return to Earth, the station remains abuzz with scientific activity. The upcoming arrival of the SpaceX Crew 10 mission, scheduled for March 12 and 13, will bring new members to the station, including NASA astronauts and McLean and Nicole Ayers, JAXA's Takuya Onishi and Roscosmos's Kirill Peskov. Their integration into Expedition 72 is a testament to the ongoing global partnerships in space research and exploration. While the crew prepares for the changeover, the ISS continues to serve as a unique laboratory for advanced scientific research in microgravity. Recent studies have explored a range of topics, from the physiological effects of exercise in space to the behavior of fluids in weightlessness. Notably, Hague conducted blood sample collections aimed at understanding bone loss during extended missions and recovery upon returning to Earth's gravity. Meanwhile, flight engineer Don Pettit worked on experiments to observe fluid dynamics, which could have implications for disease detection and material development in both space and terrestrial applications. In addition to the ongoing research, the crew is testing innovative technologies to mitigate the health impacts of long-duration spaceflight. Cosmonaut Gorbanov donned a specialized suit designed to counteract fluid accumulation in the upper body, a common challenge faced by astronauts in microgravity. This lower body negative pressure suit aims to alleviate head and eye pressure, enhancing comfort and performance for future space missions. The collaborative spirit extends beyond the ISS as well, with researchers like Dr. Sri Ramesh from Oklahoma State University receiving a NASA EPS COR travel grant to foster partnerships with NASA scientists. Ramesh's focus on 3D printing microscale functional devices highlights the potential for additive manufacturing technologies to revolutionize various fields, including space exploration and healthcare. His upcoming visit to NASA Goddard will facilitate direct engagement with ongoing projects, allowing for the exchange of ideas and the exploration of new research avenues. As NASA continues to expand its horizons in space exploration, the research conducted aboard the ISS in collaborations with academic institutions reflect a broader commitment to understanding the complexities of life in space. The implications of these studies are profound, not only for future astronauts but also for advancements in healthcare and technology on Earth. Looking ahead, The seamless transition of crew members aboard the ISS and the wealth of research conducted in microgravity will undoubtedly contribute to NASA's long-term goals. With upcoming missions and continued international cooperation, the future of space exploration remains bright, promising new discoveries that could reshape our understanding of both our universe and the human experience within it. NASA's Perseverance rover has achieved another remarkable milestone in its mission to explore the Martian surface, making headlines for its recent successful engagement with a rock that yielded unexpected geological insights. The rover, which landed on Mars in February 2021, is part of NASA's ongoing efforts to uncover the planet's past and assess its habitability. Recently utilized its powerful drill to crush a rock which scientists believe may hold clues to ancient microbial life. On March 3, 2025, during Sol 4469 of its mission, Perseverance targeted a rock formation that appeared unique in texture and composition. According to project scientist Ken Farley, this rock is unlike any we've seen before on Mars. The results from our analysis could provide critical information about the planet's history and its potential to support life. The rover's advanced suite of scientific instruments, including its onboard spectrometers, is designed to analyze the composition of the rock fragments, which are believed to be remnants of ancient volcanic activity. The crushing of this rock is not merely a feat of engineering. It signifies a deeper quest for understanding the geological processes that have shaped Mars over billions of years. The data collected from this rock could lend support to theories regarding the planet's climatic shifts and the presence of water, a vital ingredient for life as we know it. As Perseverance continues to navigate the Jezero crater, an area thought to have once contained a lake, scientists are keen to piece together how the environment has transformed and what that means for the possibility of past life. In parallel developments, discussions at the recent South by Southwest Festival highlighted NASA's broader ambitions beyond Mars, particularly the Lunar Artemis program. Astronauts from Artemis 2 shared insights into the upcoming missions aimed at returning humans to the Moon by 2025, a stepping stone towards the eventual goal of sending astronauts to Mars. This interconnected focus on lunar and Martian exploration underscores NASA's strategy to utilize experiences gained from the Moon to inform future missions to Mars. While Perseverance's current rock sampling efforts are focused on immediate geological analysis, they serve as a precursor to more extensive explorations planned for the future. As NASA continues to push the boundaries of space exploration, the implications of this research extend far beyond the red planet. The findings from Perseverance could influence how we understand planetary science, the history of our solar system, and the potential for life beyond Earth. Looking ahead, the scientific community eagerly anticipates the results from Perseverance's latest endeavors, as they could redefine our understanding of Mars and its capacity to support life. The interplay between lunar missions and Martian exploration may soon provide a clearer roadmap for humanity's future in space, paving the way for deeper exploration and discovery in the years to come. As we continue to unlock the secrets of Mars, each new mission and each rock analyzed brings us one step closer to answering the fundamental question of whether we are alone in the universe. In a disappointing turn of events, NASA's latest lunar mission has concluded prematurely, with the private lander Athena, developed by Intuitive Machines, officially declared inoperable after it landed sideways in a crater near the Moon's south pole on March 6, 2025. The mission aimed at advancing lunar exploration under NASA's Commercial Lunar Payload Services (CLPS) initiative saw the lander fail to reach its intended site and subsequently lose power just 12 hours after touchdown. Athena was designed to carry a suite of scientific instruments, including a drill intended to explore lunar soil and search for water ice, a crucial resource for future human missions. The lander was supposed to touch down at Mons Mouton but ended up over 1,300 feet away from the target, on its side in frigid conditions that hindered its solar panels from capturing sunlight. This malfunction prevented the lander from fully activating its instruments, which were critical for conducting various scientific experiments. Before going silent, Athena managed to transmit about 250 megabytes of data back to NASA, including images of its precarious position and initial readings from its scientific instruments. Notably, the mass spectrometer observing lunar operations solo detected elements potentially linked to the lander's propulsion system, while the lunar drill demonstrated its operational capabilities, albeit without penetrating the surface due to the lander's overturned state. Nikki Fox, Associate Administrator for Science at NASA, acknowledged the challenges of landing in such a scientifically rich yet difficult region. Each success and setback are opportunities to learn and grow, Fox stated, emphasizing NASA's commitment to using the lessons learned from this mission to enhance future lunar and Martian exploration efforts. The setback is particularly poignant as this represents the second consecutive failure for Intuitive Machines following a similar incident with its first lunar lander Odysseus, which also toppled during its descent. This time around, the company faced significant pressure to achieve a successful landing, especially after the recent success of Firefly Aerospace's Blue Ghost lander, which successfully deployed multiple instruments and met mission objectives just days prior. Joel Kearns, Deputy Associate Administrator for Exploration in the Science Mission Directorate at NASA, expressed disappointment over the IM-2 mission but reiterated the importance of supporting commercial partners in their lunar endeavors. Empowering American companies to deliver science and tech to the moon on behalf of NASA produces scientific results and continues the development of a lunar economy, he stated. Despite the immediate challenges, the CLPS initiative remains a cornerstone of NASA's strategy to establish a sustainable lunar presence. With 2 more missions planned for Intuitive Machines in 2026 and 2027, the agency is poised to continue its partnership with commercial vendors as they navigate the complexities of lunar exploration. The broader implications of Athena's demise extend beyond just failed missions. They prompt critical reflections on the reliability of new technology and the viability of commercial lunar operations. As NASA prepares for human return to the Moon and eventual missions to Mars, the lessons learned from these early CLPS missions will be essential in shaping future strategies and technological advancements. As investigations into what went wrong with Athena continue, NASA's gaze remains fixed on the Moon's south pole, a region believed to harbor valuable resources crucial for sustaining long-term human exploration. The agency's unwavering commitment to learning from setbacks suggests a resilient path forward, one that will hopefully yield successful outcomes in the upcoming lunar missions.